Hello guys and welcome to my channel. In this session, I want to talk about risk management process, which is the fourth technical management process. Let's get started and as always, have a good one. The purpose of the risk management process is to identify, analyze, treat, and monitor the risks continually. Risk management is a disciplined approach to dealing with the uncertainty that is present throughout the entire system lifecycle. Opportunity management may be performed in conjunction with or as part of risk management. A primary objective of risk management is to identify and manage uncertainties that threaten or reduce the value provided by a business enterprise or organization. A primary objective of opportunity management is to identify and manage uncertainties that enhance or increase the value provided by a business enterprise or organization. Since risk cannot be reduced to zero, another objective is to achieve a proper balance between risk and opportunity. Risk management, as it relates to systems engineering, is defined in ISO IEC IEEE 15288 and elaborated upon in ISO IEC IEEE 16085. As stated in ISO IEC IEEE 16085, the risk management process is a continual process for systematically addressing risk throughout the lifecycle of a system, product, or service. It can be applied to risks related to the acquisition, development, maintenance, or operation of a system. When using this process for opportunity management, the above statement with the term opportunity substituted for the term risk is also true. Inputs and outputs for the risk management process are listed in this slide. The risk management process includes the following activities: plan risk management, develop the risk management strategy or approach, capture the risk management process context, including risk categories, maintain the risk profile, capture the thresholds and conditions of the risks, establish and maintain a risk profile to include context of the risk and its likelihood of occurrence, severity of consequences, risk thresholds, and priority and the risk action requests aligned with the status of their treatment. Ensure updates of the risk profile are available to relevant stakeholders. Analyze risks. Identify risks consistent with the risk management strategy or approach. For each risk, estimate its likelihood and consequence of occurrence. For each risk, use the risk thresholds to evaluate the risk for potential treatment. For risks that exceed the threshold, capture recommended treatment strategies and measures. Treat risks that exceed the risk threshold. Identify a set of feasible alternatives for the treatment of risks. Establish measures to provide insight into the risk treatment effectiveness. Execute the treatments for the risks. When management action is needed for risk treatments, ensure effective coordination. Monitor risks. Maintain the record of risk items and how they were treated. Monitor high priority risks. Monitor risks and the risk management context to capture changes and update priorities and actions. Throughout the life cycle, monitor for new risks and sources of risk. When using this process for opportunity management, the above process activity description with a few adjustments in terminology and the term opportunity substituted for the term risk is reasonable. In the project planning process, a risk management plan or RMP is tailored to satisfy the policies, procedures, standards, and regulations related to and affecting the management of risk for the project. Process enablers. It has been found that an organization's structure and culture can have a significant effect on the performance of the risk management process. ISO 31000 outlines a model that advocates the establishment of principles for managing risk and a framework for managing risk that work in concert with the process for managing risk. Typical strategies for coping with risk include transference, avoidance, acceptance, or taking action to reduce the potential negative effects of the situation. Most risk management process include a prioritization scheme whereby risks with the greatest potential negative consequence and the highest likelihood are treated before those deemed to have lower potential negative consequences and lower likelihood. The objective of risk management is to balance the allocation of resources such that a minimum amount of resources achieves the greatest risk mitigation or opportunity realization benefits. Communication errors and misunderstandings can be prevented by defining and communicating the risk terminology to be used by the project and including with the project's risk management plan or RMP. Experience has shown that terms such as positive risk and concept models that define opportunity as a subset of risks serve only to confuse. Take care to define the terminology and concepts to be used by the project team and provide training to reinforce a common understanding. Practices used for writing good requirements help with risk statements. For example, one good practice for identifying and clarifying risks is to use an if situation, then consequence for stakeholder pattern. This pattern helps to determine the validity of a risk and assess its magnitude or importance. Risk management is most successful when risk based thinking is embraced and integrated into the culture. All personnel are responsible for identifying risks early and continuously throughout the project lifecycle. Negative feedback toward personnel who identify a potential problem will discourage the full cooperation of engaged stakeholders and could result in failure to identify and address serious risk laden situations. Conduct a transparent risk management process to encourage all stakeholders to assist in risk mitigation efforts. Some situations can be difficult to categorize in terms of probability and consequences. Involve all relevant stakeholders in this evaluation to capture the maximum variety in viewpoints. Risk measurement is not an exact science. Variation in stakeholder perspectives, perceptions, and tolerance levels, along with high uncertainty in available data, can make reliance on quantitative measures of risk insufficient. For example, some low likelihood, high severity risks might require treatment and monitoring regardless of the estimation likelihood of occurrence. External risks are often neglected in project management. External risks are risks caused by originating from the surrounding environment of the project. Project participants often have no control or influence over external risk factors, but they can learn to observe the external environment and eventually take proactive steps to minimize the impact of external risks on the project. The typical issues are time dependent processes, rigid sequence of activities, one dominant path for success, and little slack. Definitions of risk. Few terms used in engineering have as many different published definitions as the term risk. In practice, risk terminology and concepts vary considerably across industries. However, most published definitions of risk align with one of two concept models. There are two prominent definitions of risk that capture the essence of both concepts. 1. The effect of uncertainty on objectives. 2. The combination of the probability of occurrence of harm and the severity of that harm. Both definitions may be used in an SE project. The first definition includes the concept that effects may be negative or positive. In this respect, the first definition accommodates use of the second definition. In SE, it is common to use the term risk when referring to scenarios with a negative effect, and the term opportunity when referring to scenarios with a positive effect. The second definition, which accommodates only negative effects, is commonly used in safety engineering, and its use may be required in order to demonstrate compliance to risk management standards and regulations applicable to products and systems that impact public health, safety, and security. For example, in the medical industry, particularly for medical devices, risk management is often centered on product or patient and user. Safety risk, referred to as system safety in this video. Evolving risk and opportunity management concepts. Traditionally, risk has been defined as the likelihood of an event occurred coupled with a negative consequence of the event occurring. In other words, a risk is a potential problem, something to be avoided if possible, or its likelihood and or consequences reduced if not. As a corollary to risk, we can define opportunity as the potential for the realization of wanted positive consequences of an event. The idea of considering opportunities and positive outcomes in addition to negative outcomes as an integral part of a risk management process has gained favor with some experts and practitioners. New risk and risk management concepts intended to support this broadened scope for risk management are evolving. The measurement of risk has two components: the likelihood that an event will occur, the undesirable consequence of the event if it does occur. The generic consequence or likelihood matrix in this figure is a way to display risks according to their consequence and their likelihood, and to combine these characteristics to display a rating for risk level. The combination of low likelihood and low undesirable consequences gives low risk, while high risk is produced by high likelihood and highly undesirable consequences. Risk prioritization and decision rules, such as the level of management attention or the urgency of response, can be linked to the matrix cells. Note that this generic matrix is conceptual and cannot be applied without careful customization to address the specific project. Detailed guidance and examples for designing rating scales and matrices suitable for use on specific projects, products, and systems are provided in IEC 31010. A positive consequence scale may be used in the matrix shown in this figure, thereby changing the outcome adjective from undesirable to desirable and the cells in the matrix from risks to opportunities. Note that the foundational concept and structure of the matrix diagram remains the same. Systems engineering and project management are all about pursuing an opportunity to solve a problem or fulfill a need. Opportunities enable creativity in resolving concepts, architectures, designs, and strategic and tactical approaches, as well as the many administrative issues within the project. It is the selection and pursuit of these strategic and tactical opportunities that determine just how successful the project and system will be. Of course, opportunities usually carry risks, and each opportunity will have its own set of risks that must be intelligently judged and properly managed to achieve the full value. There are the risks that must be managed to enhance the opportunity value and the overall value of the project. Opportunity management and risk management are therefore essential to and performed concurrently with the planning process, but require the application of separate and unique techniques that justify these distinct technical management elements. Balancing project risk and opportunity management for systems engineering. No realistic project can be planned without risk. The challenge is to define the system and the project that best meet overall requirements, allow for risk, and achieve the highest chance of project success. This figure illustrates the major interactions between the four risk categories: technical, cost, schedule, and programmatic. The arrow labels indicate typical risk relationships, others are possible. The risk management process is used to understand the potential cost, schedule, and performance, that is, technical risks associated with a system, and then take a proactive, structured approach to anticipate negative outcomes and respond to them before they occur. With respect to opportunities, this process is used to understand the potential cost, schedule, and performance, that is, technical improvement opportunities associated with a system, and then take a proactive, structured approach to defining potential positive outcomes and responding to them by adopting the best candidate improvements before the window of opportunity is missed. Care is taken to consider new and increased risk created as a result of pursuing a new opportunity. This practice can help identifying unintended negative consequences that might be introduced by the proposed change. Integrating risk management. Integrating risk management with all organizational processes improves the performance of risk management while gaining efficiencies. Risk management in life cycle processes provides a methodical approach for the integration of risk management and risk based thinking into all systems engineering life cycle processes. Organizations typically manage risks and opportunities of many types across and throughout the organization. Risks and opportunities associated with system development should be managed in a manner consistent with the organization's overall risk and opportunity management strategies. Risk management and the system lifecycle. Once the scope and context of a system have been established from a hierarchical standpoint, it is possible to define and model the system and its associated risks in relation to its life cycle, that is, the differences in the risks in different life cycle stages. For example, risks in the concept stage are quite different than the risks in the retirement stage. It is often necessary to consider risks in other stages while performing activities in the current stage. Risk assessment techniques. Risk assessment techniques provide Details, descriptions, and application guidance for over 30 assessment techniques ranging from brainstorming and checklists to failure mode and effects analysis or FMEA, fault tree analysis or FDA, Monte Carlo simulation, and Bayesian statistics and bias nets. Although a comparable set of published techniques for opportunity management is not available, it is notable that ISO IEC 31010 is not without mention of opportunity and contains the strength, weakness, opportunity, and threat analysis technique. In addition, many of the technique in ISO IEC 31010 can be used to assess positive outcomes as well as negative outcomes. For example, FDA can be used to perform success tree analysis and techniques such as brainstorming, checklists, Monte Carlo simulation, and Bayesian statistical analysis, or broadly used for most any purpose, including the assessment of opportunities. A variant of SWOT analysis that is not mentioned in ISO IEC 31010 is threats, opportunities, weakness, and strengths, or TOWS, which puts the emphasis on the external environment, threats, and opportunities rather than on the internal environment or strengths and weaknesses. Risk treatment approaches. Risk treatment approaches, also referred to as risk handling approaches, are often established for the moderate and high risk items identified in the risk analysis effort. These activities are formalized in the RMP. There are four basic approaches to treat risks. 1. Acceptance. Accept the risk and do no more. 2. Avoidance. Avoid the risk through change of requirements or redesign. 3. Control or mitigation. Taking actions to reduce the risk by expanding budget and or other resources to reduce likelihood and or consequence over time. 4. Transference. Transfer the risk by agreement with another party that it is in their scope to treat. Look for a partner that has experience in the dedicated risk area. The following are some of the steps that can be taken to avoid or control unnecessary risks. Requirements scrubbing. Requirements that significantly complicate the system can be scrutinized to ensure that they deliver value equivalent to their investment. Find alternative solutions that deliver the same or comparable capability. Selection of most promising options. In most situations, several options are available. A trade study can include project risk as a criterion when selecting the most promising alternative. Staffing and team building. Projects accomplish work through people. Attention to training, teamwork, and employee morale can help avoid risks introduced by human errors. For high risk technical tasks, risk avoidance is insufficient and can be supplemented by the following approaches: early procurement, initiation of parallel developments, implementation of extensive analysis and testing, contingency planning. For each risk that is determined credible after analysis, a risk treatment plan should be created that identifies the risk treatment strategy, the trigger points for action, and any other information to ensure the treatment is effectively executed. The risk treatment plan can be part of the risk record on the risk profile. For risks that have significant consequences, a contingency plan should be created in case the risk treatment is not successful. It should include the triggers for enacting a contingency plan. Risk monitoring. Project management uses measures to simplify and eliminate the risk management process. Measures can help identify new risks as well as provide insight into the effectiveness of the risk treatments. Each risk category has certain indicators that may be used to monitor project status for signs of risk. Tracking the progress of key system technical parameters can be used as an indicator of technical risk. The typical format in tracking technical performance is a graph of a planned value of a key parameter plotted against calendar time. A second contour showing the actual value achieved is included in the same graph for comparative purposes. Cost and schedule risk are monitored using the products of the cost or schedule control system or some equivalent technique. Normally, cost and schedule variances are used along with a comparison of tasks planned to tasks accomplished.